hello, and like, thanks Rob for introducing me, and like, thanks for the boss committee for giving me a chance to talk about the TGAC browser. So it's like the first talk for the TGAC browser in like the international meeting. So I'll just go from the beginning to the end. So like I'm working at the genome analysis center in UK, and it's like it's on the East Coast, but it's not US. It's in the UK, like East Coast of the UK, and so like what is the Genome Browser? Like Thomas gave a talk. It's like so many like genome browsers available, like Gbrowse, and like BioDali, and so it's like Genome Browser is like the simple interface to visualize the genomic information on the X and Y coordinates. So like if you see here. Yeah, like if you see here, like normally it's like the X coordinate is like the genomic region, and like the Y coordinate is like the genomic features. It's like the different features like aligned on the genomic region from 1 to n, like from beginning to the end. So like the TGAC browser is just like follows the same style, like the same standard of like X and Y coordinates. Anyway. It just like follow the same standard of the X and Y coordinates. So it's like if you see here, it's like we have like the position on the left corner, then it's like the few consoles on the top, and it's like we have like the tracks and setting buttons, and like the save and share sessions. So it's like you can see like save your session and like just share the letter into your collaborators or for the future purpose. And like you have like the chromosome views on the top. Like if you have chromosomal information, you can see like all the chromosomes, and like then it's like we have different. It just like show all the different tracks, so like all the different features as a track is like one by one, and like you can like use like a Google Maps. You can like drag around and it's like rearrange the tracks like for your choice, and like completely developed at TGAC from the scratch, and like TGAC browser works on the top of Ensembl. So it's like Ensembl developed like with collaboration with EBI and Sanger, and it's like very old and like very very properly formatted, and it's like very useful. So like people don't need to change people don't need to introduce new file format or like new data format. Like if you have Ensembl format, you can just use TGAC browser on the top. So it's like how is the structure of TGAC browser? So like main structure is like it's not lightweight. It's like we have server and the client. So like we use server for the heavy database query. So it's like and then we send all the data to the client in form of text, and then it's like we generate all the graphics and like render on the client side. So it's like client's computer is like free from the heavy query, and like server does all the job. So it's like best of both. So you can use like heavy server for your like the big database query, and like you can use like web browser, so you can share your data from anywhere in the world. And so it's like how it looks like the programmers use is like how it does it look. Like on the server we have like the Java infrastructure, and on the client we have we use JavaScript, CSS, like JSP and SVG for the to make dynamic HTML codes to visualize all the genomic information. So like on the server side we have like Java classes, and then we use like a Java SQL Java SQL DO to get all the data from the Ensembl core database. So like Java SQL DO converts all the Ensembl table data to the JSON object, and then the JSON object goes to the client, and then it's like client generates all the images from the JSON object. For the when client says when client sends a query to server like give me all the genes from this to this region for this reference. So it's like Java classes will call SQL DO, and then like all the genes will go to the client as a JSON text. So like the data transfer is like just like text. Like data transfers the size is very small. So like browser works very fast. And say like supported data on the TGAC browser. So like we support almost all the data from the Ensembl core schema. Then it's like we support SAM and BAM file directly, like without any conversation. And we support big and GFF and the VCF. So like from the Ensembl core schema, we can visualize all the different things like genes, SNPs, repeats, assembly. As a standard from here you can see like the genes with the exons and the introns, and like different SNP, like the different triangle with the different colors based on the transition and the transversion, and like all the repeats. And here you can see like the assembly tracks, like this is like the clones mapped to the like context or scaffold. And this is like the alignments, like mapped to the reference. And it's like we visualize markers on the chromosomal information. Like you can see markers on the side of the chromosome view. And it's like this is the example for the BAM ensemble. So it's like we visualize BAM ensemble directly from the file without any conversion. So it's like this is the example for the colored paired zits. So it's like the blues are the first in the pair, and the browns are the second in the pair. And you can see some of the oranges. It's like not paired data. And it's like you can see like the empty regions in the middle. It's like these are the deletions of the. So like this data was mapped to the. Like this is the example of the RNA-seq data mapped to the reference. So it's like these are the introns that are not mapping anywhere. And the next example is also of the big and big files. So it's like we can visualize it like the positive and the negative data on the different level. It's like the positive like. In this example, we can see like the positive data on the top with the red color and the negative data on the bottom as a blue color. So it's like you can specify your colors and all the stuff, and you can like make customize for your own use. And this is the example for the VCF and the GFF file. So it's like we can visualize the variant file like directly from the VCF, and it's like you don't need to convert. So it's like the different bases is like visualized in the different colors. So you can visualize introns, you can visualize like insertions and deletions and the mutations with different. So like this is very useful because it just shows them in a different color, and you can see like insertion and deletion clearly. And the second example is like the data comes from the GFF file directly. So you can it's the same as the genes data from the Ensembl core, but it's just like from the GFF. So it's like you don't need to convert your data to Ensembl to the Ensembl format, and you can visualize directly GFF on the browser. So like how you put non-Ensembl data into TGAC Browser, because like we get all the data from the Ensembl tables. So like to add non-Ensembl data to the TGAC Browser, you just need to modify one table called analysis description, and it's like you just need to put all the information in the one column of the analysis description. It's called the web data column. It's like the last column of the table, and it's like you just need to put here like your own color and the source for the file, and it's like a file path. So like this file needs to be on the same server of the browser, and you can it's like group the. Like you can group the tracks, like depends on, so like they will be grouped together on the browser, so it's like easy to find them. Like when you have so many tracks, it's like the grouping is very helpful. So you can just like specify your file like big or BAM or some. So it will read the file from the source, and then it will visualize on the browser. And like the different like TGAC Browser can visualize the data in the different visual types. Like the previous examples is like the typical visualization, like the common between different browsers, like the genes and SNP and alignments. So it's like here we can like the automatically the automatically like we choose the visual type, like when you have like 10,000 SNPs, so like you don't want to like look at each and every SNP, so you can just like visualize like the bar chart, so it's like you can see like the overview of all the data, so like where the data is more condensed and where is empty. And it's like when you cross like so many like so much data, then it's like the bar chart is kind of very much memory consuming as well. So it's like when you have like 1 million data or something, so we just convert them to the heat map. So it's like it just like the total overview of the data, and then you can zoom in and look at each and every feature. And the next bit is like the searching. So you can it's like search with the keywords. So like if you have chromosomal information, you can like get all the results on the chromosome. Then you can like click on the hit, on the hit, and then you get the tables, because like the hit can be like very close by. So you can like click on the one hit, and you get like the nearby hit, and then you can click on the link, and you can go to the TGAC or the browser page of the specific hit. And like if you don't have a chromosomal information, then you get like the table. So it can be, and it's like separated by the genes, transcript, go, and it can be more like alignments, repeats, like as the result come. So like this is the normal search that like almost every browser has. But in TGAC browser, you can search with the sequence. So like if you have your own sequence, but if you want to search, like where this sequence is like match with your match in the database. So like we integrated something called Blast Manager. So it's like you can put your sequence. Like this is a part of TGAC browser. So you can put your sequence here, and you can choose the database and just like click and the blast type, and just like click on blast. So like it will do blast. So like you can do multiple blasts at the same time, and like it will keep on adding like the blast like the blast queries on the side. So like when the blast is finished, you get like the right sign is done, and then you can like click on the zoom, like the visual, like this button, and you can see like the result. So like you can do multiple like queries at the same time, and then you can like toggle between the results. And it's like here is a link, so you can like click on the link, and you can go to the TGAC browser page of the specific hit. So like you can search with the sequence on this browser. Is the main plus point. And another thing of the blast is like if you want to blast your gene against the database, you can like just select the feature like gene alignment or like the region from the like browser, and then like click on the blast button. So like you get the blast result as a track, and it's like the colors are based on the scoring system from the blast standard, and it's like the blocks are the like indel. So you can like click on the block, and you get like the indel information. It's like very good for the variant to get the variant studies. And then yeah, this is how like we implemented blast into the TGAC browser. So like you have three options. Like you can choose any of the options. It's like when you set up the browser. Like if you have HPC cluster, it's like we have in TGAC. So it's like you can like run blast on the HPC clusters, and then or you can like run blast on the NCBI, or you can run blast on the local machines. But like NCBI and local machine can be slow, but like when you have cluster, like any of the blast can be done like within 5 or 10 seconds, and you get results very quickly. And it's like we store all the blast files into local database. So it's like when you run like when someone runs like the same blast, like they don't need to run blast, but it's like they can just like store results from the files. So it's like very quickly. So it's like it can save like your resource and memory and all that, everything. And like another exciting thing about the TGAC browser is like the pop-up. So so like pop-up has like so many information. So like you can see like the track type and the position and the track description on the top. That's easy. Like that's normal, but it's like you have like the more buttons on the bottom. So like you can get different kind of like pasta and peptide sequences, or the blast, or like zoom. You can zoom and flag, and like there are like more options when you click on the open for more options. It's like you get like 6 or 7 more options. So I just need to skip on because I'm running out of time. And like these are some of the future works for it's in the pipeline for the TGAC browser. So it's like we want to integrate like the manual annotation, and it's like we want to integrate like Aequatus Browser. It's like this is the first mention for this coming up the new Genome browser, and it's like we want to allow like users to upload their own data from the client side, and like new visuals like Manhattan plots and the expression data on the gene. It's like you can see like our prototype example here. And it's like we want to integrate like different analysis like Hammer and Blot and the data download from the browser, and in like REST API to the Ensembl server to get all the genomes from the Ensembl, and it's like of course like still need to write a paper. And Like this is like the prototype of the mini letter. So like this will allow TGAC browser to go from read only to the read and write. So like user can like look at the feature, and if they see like is something wrong with the feature, so it's like they can edit, add or remove tracks, and then they can export data and like send the data to the curator, and then the curator can update the database. So it's like user can help to improve the genome annotation. And it's like this is the prototype version on the development. So like you can user can like change all the credentials for the tracks, and it's like they can save and it's like send the report to the curator. And even user can add new tracks. And like this is the screenshot for the Aequatus browser. So like this is on the development. It's the beta version. So it's like you can it will visualize the genetic information between various species. So like first one is like the Oryza sativa. This is rice. Then it's like this is again the Oryza sativa. Then it's like the rhodium and the brachypodium. So like you can see like the exon similarity between different genes. And then you can like get the phylogenetic tree, and you can like change the reference, and you can get more information about the homology for the genes. And like I can like we have like the demo version on this link, so you can go and check out the demo version. And like I have around 75 slides on this browser, so like you can go to the slides here and have a look at the slides. So it may take up to 1 hour or something to talk. And yeah, so like the timeline, it's been almost 3 years to like development of TGAC browser. Like we presented in different conferences, and it's like different versions out. And it's like version 2.2 will be out soon. And these are the open instances. It's on the TGAC browser website. And it's like we have full documentation for the like how to use, how to install it, and it's like how to get the TGAC browser. And you can always email us, and we can help you set up the browser. So yeah, few of the acknowledgements, like these are the people in TGAC. So it's like Rob and Jingdong is like helping me for the development of the code. And it's like when I'm like stuck something with the code, they can help me. Like Sarah and Mario for the different ideas, and it's like these are the few users in TGAC, and it's like few users outside of TGAC and our sponsors, BBSS in Transland. Yep.